Saturn is not the peaceful giant you think it is. For centuries, it has been seen as the most elegant planet in the solar system. A calm world wrapped in delicate rings, drifting quietly through the darkness. With telescopes and spacecraft images, Saturn appears smooth, pale, almost serene. Compared to the violent storms of Jupiter or the volcanic chaos of other worlds, it seems gentle, stable, and quiet. That picture is misleading. Saturn is not calm, it is not gentle, and it's certainly not peaceful. Beneath those soft golden clouds lies an atmosphere driven by immense internal heat, where winds can exceed 1,800 kilometers per hour and storms can grow large enough to circle the entire planet. Lightning flashes with energies far beyond anything seen on Earth, and deep below the clouds, pressures rise to levels capable of crushing matter into exotic forms. Even the rings, often seen as symbols of beauty, are not tranquil structures. They are made of billions of chunks of ice and rock orbiting at enormous speeds, colliding constantly, grinding themselves down as gravity slowly pulls them toward the planet below. From a distance, Saturn looks like a masterpiece of cosmic symmetry. Up close, it is a world of motion, pressure, and relentless energy, a place where the forces shaping the planet never truly rest. We tend to think of Saturn as a frozen relic, a distant giant shaped long ago and left unchanged. But Saturn is not static. It is dynamic, evolving, and far more active than its calm appearances suggest. To understand why Saturn is far more dangerous than it looks, we have to look past its beauty and understand what this planet really is. Not a solid world, but a massive sphere of gas shaped by gravity, heat, and powerful atmospheric currents. If you were able to fall towards Saturn, you wouldn't encounter a solid surface. There is no ground waiting beneath the clouds, no clear boundary where sky becomes land. Instead, the atmosphere simply grows thicker and denser the deeper you descend, transitioning gradually from gas to fluid under the immense pressure. Saturn is made primarily of hydrogen and helium, the same elements that make up the Sun, but under very different conditions. Gravity compresses these gases into layers, each with increasing temperature and pressure, creating an environment unlike anything on Earth. The upper atmosphere appears calm from a distance, but even here, powerful jet streams circle the planet, driven by heat rising from deep within. One of the most surprising things about Saturn is how light it is for its size. Despite being nearly 10 times wider than Earth, Saturn has the lowest density of any planet in the solar system. If you could somehow place it in a vast ocean large enough to hold it, Saturn would float. That doesn't mean it's gentle, only that its enormous size is balanced by a composition dominated by gas rather than rock. As it descends deeper into Saturn's atmosphere, temperatures climb rapidly. Clouds give way to layers of ammonia ice, ammonium hydrosulfide, and water vapor, each forming distinct cloud decks shaped by atmospheric currents. Below these layers, the atmosphere becomes a supercritical fluid, neither gas nor liquid, but something in between, flowing slowly under the crushing pressure. Eventually, hydrogen itself begins to behave in unfamiliar ways. Under extreme compression, it transitions into metallic hydrogen, a state in which it can conduct electricity like a metal. This layer is thought to play a key role in generating Saturn's magnetic field, creating powerful radiation belts that extend far into space. But Saturn's internal heat is just as important as its composition. The planet radiates more energy than it receives from the Sun, a sign that heat from its formation still escapes from deep within. This energy fuels atmospheric motion, driving winds and storms across the planet at incredible speeds. And those winds are not just fast, they're among the fastest anywhere in the solar system. At Saturn's equator, winds can exceed 1,800 kilometers per hour, far faster than the most powerful hurricanes on Earth. At these speeds, entire cloud systems are stretched into long bands that wrap completely around the planet, driven by powerful jet streams that never truly stop moving. These winds are not surface phenomena. They They extend deep inside the atmosphere, fueled by the heat rising from Saturn's interior. Unlike Earth, where the weather is powered mainly by sunlight, Saturn's atmosphere is driven largely by internal energy left over from its formation, creating a world where motion is constant and immense. From orbit, these currents appear as alternating light and dark bands, flowing east and west in parallel streams. Where these streams meet, turbulence forms, creating swirling vortices that can persist for years or even decades. But every so often, Saturn produces storms on a scale that dwarfs anything seen on our planet. Roughly once every few decades, a massive eruption breaks through the upper cloud layers, a phenomenon known as the Great White Spot. These storms begin as bright plumes that rapidly expand, eventually growing large enough to encircle the entire planet. As they spread, lightning flashes deep within the clouds, releasing energy thousands of times greater than a typical lightning bolt on Earth. When spacecrafts like Cassini observed these storms, they detected powerful radio emissions created by lightning discharges, confirming the enormous electrical activity hidden beneath the clouds. These planet-wide storms can take months to fully develop, reshaping the atmosphere as they move, before slowly dissipating back into the ground flow. But even outside these rare events, Saturn's atmosphere is anything but calm. Turbulence exists at every scale, from massive jet streams to smaller rotating storms scattered across the cloud tops. And nowhere is this atmospheric motion more mysterious than at Saturn's poles. Because at the North Pole, Saturn hosts one of the strangest weather systems in the entire solar system, a storm unlike anything found on any other planet. At the center of Saturn's North Pole lies a massive six-sided storm, stretching more than 30,000 kilometers across, large enough to swallow Earth several times over. Known simply as Hexagon, this strange geometric pattern was first discovered during the Voyager flybys in the early 1980s and has persisted ever since, remaining stable for decades despite the turbulent atmosphere surrounding it. Unlike typical storms, the hexagon is not a swirling vortex, but a jet stream flowing in a nearly perfect polygonal shape, with each side extending thousands of kilometers before sharply turning to form the next. Winds within the structure can reach hundreds of kilometers per hour, yet the overall shape remains remarkably steady, rotating in sync with the planet beneath it. At its center sits a powerful polar vortex, a massive hurricane-like storm with a clearly defined eye, surrounded by towering cloud walls. The structure resembles a hurricane on Earth, but on a scale far beyond anything our planet could sustain. Lightning flashes deep within the clouds, and powerful updrafts pull material high into the atmosphere, creating a constantly shifting landscape of clouds and storms. Scientists believe the hexagon forms due to a complex interaction between atmospheric waves and Saturn's rapid rotation. Laboratory experiments have shown that rotating fluids can naturally form polygonal patterns under certain conditions, suggesting that the hexagon may be a stable wave trapped within Saturn's jet stream. But despite decades of study, the exact mechanisms that maintain its precise shape remain an active area of research. The persistence of this structure reveals just how stable Saturn's atmospheric currents can be, even in the midst of extreme winds and turbulence. It is a reminder that the planet's atmosphere is not random chaos, but a dynamic system shaped by deep internal energy and powerful rotational forces. And while the hexagon is mesmerizing, it is only a small window into what lies deeper below, because the true extremes of Saturn are not found in its clouds, but far beneath them, where pressure and temperature rise to levels that push matter into unfamiliar states. As you descend deeper into Saturn, the atmosphere transitions from turbulent clouds into an ocean of compressed gas, growing hotter and denser with every kilometer. There is no clear boundary, no surface where you could stand, only a gradual shift into a world of crushing pressure and rising heat. Temperatures climb into thousands of degrees, and the weight of the overlying atmosphere increases dramatically. Any spacecraft attempting to descend too far would quickly be destroyed. Its structure crushed long before reaching the deeper layers, Even the strongest materials we know could not withstand these conditions for long. Far below the visible clouds, hydrogen, the most abundant element in the universe, begins to behave in extraordinary ways. Under immense pressure, it transitions into metallic hydrogen, a state where it conducts electricity like a metal rather than behaving as a gas. This layer is believed to surround a dense core composed of heavier elements, though the exact structure remains uncertain. The movement of metallic hydrogen within Saturn generates powerful electrical currents, producing a vast magnetic field that extends far into space. This magnetic environment traps high-energy particles, creating radiation belts that would be lethal to unprotected spacecraft or human explorers. Saturn's magnetic field is unusually symmetrical compared to other planets, a mystery that scientists are still trying to understand. But despite its symmetry, the field is incredibly powerful, shaping the space environment around the planet and influencing the behavior of its rings and moons. The deeper you go, the more Saturn reveals itself as a world defined by pressure and energy rather than solid ground, a planet where familiar concepts like surface and atmosphere begin to lose meaning. And yet, some of the most visible signs of Saturn's dynamic nature exist not deep within the planet, but far above it, orbiting in delicate arcs of ice and rock that appear almost fragile from a distance. Saturn's rings may have the most recognizable feature of any planet in the solar system. From afar, they look smooth and almost weightless, thin bands of light suspended perfectly around the planet. But up close, the rings are anything but calm. They're made of billions of individual pieces, fragments of ice, rock, and dust ranging in size from tiny grains to chunks as large as houses. Each piece moves at incredible speeds, orbiting Saturn under the influence of gravity. In the densest parts of the rings, particles collide constantly, bouncing and grinding against each other in a slow-motion chaos that never truly settles. Traveling through the rings would be extraordinarily dangerous. Even small fragments moving at orbital velocity could destroy a spacecraft, and larger chunks would be catastrophic. What appears from a distance as a smooth structure is, in reality, a vast debris field stretching hundreds of thousands of kilometers across. The rings are also dynamic. Waves ripple through them as Saturn's moons exert gravitational pulls, creating spiral patterns and gaps that shift over time. These interactions constantly reshape the structure, preventing it from ever becoming truly stable. And Saturn is slowly losing them. Through a process known as ring rain, particles are gradually pulled inward by Saturn's gravity, spiraling down into the atmosphere. As they fall, they break apart and vaporize, contributing material into the upper atmosphere. For millions of years, this process will continue, thinning the rings until they eventually disappear entirely. The rings that make Saturn so iconic are temporary, a fleeting feature on cosmic timescales. We happen to exist at the time when they are still bright and visible, but they will not last forever. What looks timeless is actually fragile, and as Saturn continues to evolve, both its atmosphere and rings will slowly change, reshaped by the same forces that created them billions of years ago. From a distance, Saturn appears almost perfect, a planet defined by symmetry and elegance, its rings forming one of the most recognizable silhouettes in the solar system. It's easy to see why Saturn has long been associated with calmness, a quiet giant far removed from the chaos of the inner planets. That calmness is an illusion created by distance and scale. Up close, Saturn is a world of constant motion, shaped by powerful atmospheric currents, immense internal heat, and forces far beyond anything experienced on Earth. Winds race around the planet at incredible speeds. Storms erupt that can engulf the entire globe. Deep within, pressures transform simple elements into exotic states of matter, and above it all, the rings, fragile and temporary, slowly erode over time. Saturn is not dangerous in the way we instinctively imagine danger. There are no volcanoes, no solid ground to collapse beneath your feet, no fiery landscape. Instead, the danger lies in the sheer scale of its environment, in pressures that crush, winds that never stop, and a gravitational pull that shapes everything around it. It is a reminder that beauty in the universe does not always mean gentleness. Saturn's elegance comes from balance, a balance between gravity and motion, between heat and pressure, between stability and change. But that balance is dynamic, constantly shifting, revealing a planet that is far more active and complex than its peaceful appearances suggests. In many ways, Saturn represents the dual nature of the cosmos itself, a place where order and chaos exist together, where something can appear calm while immense forces operate just beneath the surface. And perhaps that is what makes Saturn so fascinating. It is not just a beautiful planet with rings, it is a reminder that even the most serene worlds can hide extraordinary power. Join us next time as we explore more mysteries of the universe.